Section 5.3, solving polynomial equations, day 2. And we're going to do factoring, right? So basically, we're going to take high-level polynomials, x cubed, x to the fourth, stuff like that, and break it down into smaller pieces using factoring. And why there's so many different lessons for this section is there's a lot of different ways to factor. So I tried to make a summary of all the stuff, all the different ways to factor. And first and foremost, always check for GCF, right? That's always going to be your first step. And then these are some different patterns or situations that you want to watch for. So um, this video is actually going to cover number 1 and number 2. 1 is really a review. It's just square minus square. So some examples of that are like x squared minus 25. 25 is a square number, and so you can just make two little binomials with x and x for the x squared, and then multiply to negative 25 and add up to 0 in the middle is just minus 5 and plus 5. Okay, and that's a pattern you just have to recognize. And knowing your square numbers, like, oh geez, what's a harder one? 196 happens to be a square. That actually factors into like x minus 14 and x plus 14. So knowing your perfect squares is pretty helpful for identifying that factor case. Okay, and then there's also a case where it's a cube and a cube. So we have one for like square minus square, and we're gonna have a new pattern for cube, which is usually one of the harder things to do all year long. So we'll hit that in this video. All right, so general big picture again is we know how to solve linear stuff, right? You just add 6, divide by 2, blah, 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 right? You know how to solve linear. That's just algebra steps. If you're solving a quadratic, right, we know how to solve those. We did that in chapter 4. There's all these different methods for solving a quadratic that you see here, right? And then if it's higher than that, our goal is just to break it down into these pieces that we already know how to solve, right? So as an example, we're going to take like this cube today, and this is how you factor this cube pattern. And now we have a linear thing, and we could solve that to get an answer of 4. And then this thing, we could try and factor it more, but this particular one doesn't factor anymore. So we could actually just use our quad formula or one of these other methods here to find the two answers to this. Okay, so we're breaking it down into smaller pieces. Okay, so here's first example. First off, give it a shot. You can think about how many answers you'd have, but we want to factor first. We already got 0 on one side. Hopefully you had a chance to try it. So always check GCF first when you factor. Okay, so on this one, you can pull out an x, leaving you with x squared minus 25. And then, oh, hey, this is square minus square. So you can break that into this part here, x and x, and then plus 5 and minus 5. Okay, so at this point, we factored it into 3 little linear things. And now we just say, well, if all of it has to multiply to 0, then you could put a 0 in front. So you could have x equals 0 as one answer. Or you could have this little binomial be a 0, in which case you'd get negative 5. Okay, or you could have this little binomial equal 0, in which case x would be 5. Right, if you'd add 5 to both sides there. Okay, so boom, we got our 3 answers. All right, I'll have you try one more like that. All right, so we're going to factor it apart. So we want to get 0 on one side first. So we're going to minus 18x. Okay, and now the only way I know how to solve a cube is to break it down into smaller pieces. So I can take out an x, but also I think 2, right? 2 divides both of these evenly, so I'm going to pull out 2x, leaving you with 4x squared, and then a minus 9. Okay, and then this one is a little bit harder to recognize, but this is still a square minus square. And so I think a good way to think of it, and again, I knew that because 4 is a perfect square, x squared is a perfect square, and so is 9. Right, and so basically I think what and what here would make 4x squared, and so I know I need a 2x and a 2x, and then to make the minus 9 I need a minus 3 and a plus 3. Right, and then set all those parts to 0, and then solve them to get your 3 answers. Okay, and I'm going to solve these really fast just to save time. So this one, divide by 2, you'd get 0, Here you'd add 3 and divide by 2, so you'd get 1.5. Here you would minus 3 and divide by 2, so you'd get negative 1.5. And those are our 3 answers to that cubic polynomial. Okay, so we just got done doing problems that had the square minus square in them. So we're going to learn about cube patterns, and there's actually 2 of them because you can factor, for the square one, it had to be a minus between them, but for cubes, you can actually factor a cube plus b cubed or a cube minus b cubed. These formulas will be given to you on the test, but I would definitely write them down in your notes to help with the homework. So basically, it's just a pattern. So if it's a cube plus b cube, it factors into this binomial times this trinomial, right? And it's a really weird problem because you have this little thing and it factors into something really big, which is kind of surprising. And I could do a 28-minute lecture on why that's true, but I'm going to spare you the details and just say that you know that this has to factor into this thing times this thing. Okay, and if it's minus, it's pretty much the same pattern. It just flips the signs that are right there and right there. Okay, so we're going to do a couple cases. This first one we'll just kind of do together, and then if you want to try the next parts, you can. Oh, actually, we should do something else first. Let's do a few cube numbers, because just like square minus square, it's helpful to know them. So like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and I think the highest maybe you'd see 6 cubed is 216. So those numbers are good to know for these problems. Okay, and in fact, on this one, here's one of our cube numbers right there. So we have a cube thing plus a cube thing, so it's going to factor to this pattern. And the first step is often one of the hardest ones, where we have to figure out what is A and B. So this little pattern represents A cubed plus B cubed. And so in this particular case, this x cubed is the A cubed part. Okay, so to figure out what A is, we just have to say, I kind of think of it as this way, what times what times what will give us the x cubed, right? What thing times itself 2 more times will give us x cubed, and in this case, it's just x. So another way to think of it is you could like kind of just cube root it, right? It's cube root both parts, and so you could say that the A is just equal to x. For B, right, so B cubed is the 8, and so we're going to do the cube root here, or use that chart from the last slide to just get 2. Like the cube root of 8 is 2. So B is going to be 2. Okay, now that we've got those 2 things identified, we're going to plug them into this pattern. So basically we're going to say x cubed plus 8. That's our original thing. This thing explodes to a plus b. So x plus 2 using our values from over here. And then square the a part. So let's see. Oops, sorry. Here's a and b. So square the a part would be x squared minus a times b. So a times b would be x times 2, or 2 times x. And then b squared would just be 2 squared, so that's just going to be 4. Okay, and we still have it all equal to 0. We just exploded it. All right, and at this point, again, our goal is to solve. So we could try to factor this further, this trinomial, right? Like try and factor it into 2 little binomials. But on these questions, it won't work. If we think about 4, right, the things that multiply to 4 are 1 and 4, 2 and 2, and neither of those add up to -2. There's no way to make a -2 using those numbers. Right, so long story short is that doesn't factor. So we've got to use one of our different methods for solving x squared. Right, so at this point, we can just take the x plus 2, set that equal to 0, and that gets you one of your answers is -2. Okay, and then here, generally these are going to be 2 imaginary answers. All right, and you're going to want to use your quad formula then to find the 2 imaginary answers. So I'll get that on here for you. I'm going to start with the Oh, and one thing I should note is we had a and b over here, but now it's like a new sort of problem, right? So now we're trying to solve this quadratic over here. So we have a new ABC. So that's kind of confusing to students, is they think you just use these a and b values over here, but really you take them from this quadratic equation. So a is 1, b is -2, and c is 4. Okay, so we're going to do our little formula, and I'm going to start with the b squared minus 4ac part. So -2 squared minus 4 times 1 times c of 4. So I get 4 minus 16, which is -12. And then I'm going to do simplest radical form for that. So that should split. Sorry, I'm running out of space here. Should split to the square root of 4, square root of 3, and square root of -1. Pull off the perfect square of 4. So we get 2i for the negative square root and 3. So my formula then would be x equals the opposite of b plus or minus 2i square root of 3 all over 2 times a. So just 2. And then again, that will divide out. That 2 will evenly divide out. So I'll have 1 plus or minus I root 3, or 1 I root 3, however you want to write it. Okay, and that gets us a pair of imaginary. So my three answers were -2 and then these two imaginary. Okay, and that's a lot of steps. I'm not going to do all the steps on the remaining problems because I think that I just want to work on just the factor step, right? Because I think, long term, the other, you hopefully know how to do the quad formula, right? So we'll focus on the other stuff. Okay, so here's a second one where it's the subtract pattern. So I have my subtract pattern here. And again, we got to start by figuring out what is A and B. So for sure, pause the video and see if you can figure out A and B. Okay, so this x cubed is the a cubed. So I have to think number times whatever. That'll give me x cubed. And hopefully you'll figure out that you just need an x. You could also do the cube root of this would be another way to think of it. But a is just x. And then for b cubed is 27. So again, if you take the cube root of that, you just get 3. Okay, so a and b, we're going to use those to factor. So over here we do x minus 3, and then a squared would be x squared, plus a times b, so that'd be 3x, and then 3 squared is just 9. Okay, so we've taken and we've factored this little thing apart to that. Okay, and then at this point, one of the answers is going to be 3. If I set this dude to 0, I get 3. And then this part again won't factor anymore, so you have to use your quad formula. Okay, so again, I'm not going to take the time to go through all that, but you do your quad formula to get 2 more imaginary answers. And one more time, when you do the quad formula here, you just do new ABC with A of 1, B of 3, and C of 9. So in the event that you did the quad formula and want to check your work, here's what it would look like, and you get 3 answers. So we have 3 as a real answer, and then these 2 imaginary answers. One thing I forgot to mention here, students oftentimes ask me, like, it should B be -3 here because this is a minus sign in the original question right up here. And the answer is no. The differences come out in the pattern, the factor pattern, but these A and B initially, A and B will always be positive values. So just kind of do the cube roots and then don't worry about that, the rest of it. All right, I do want to throw one more at you. I know I'm running out of time, so see if you can do A and B and then do the factor pattern. Okay, so real quick, a cubed is this first part. So you have to think what times what will give us 8x cubed. And hopefully you can figure out that that is 2x. You have 2x times 2x times 2x. And then cube root this last part to get 3. And again, not -3, but just 3. Cube root this. Okay, and then into the pattern, I'll have 2x minus 3. So I'm just plugging in for a and b. A squared, I got to square the whole thing, so I got to do 2x squared. So this is 4x squared. A times b is 6x, and then b squared is 9. right? And then you would set it to 0 and solve.